In this video, I'm going to talk about graphing quadratics in factored form. An equation in factored form is written as a product, and we'll review the coefficient here, a, when we're talking about the graph of a quadratic, a parabola, tells us whether the graph is going to open up or down. A positive a tells us that our parabola opens up. And a negative a value tells us that our parabola is going to open down. The factors are going to tell us about our x-intercepts. To get our x-intercepts, we set the factors equal to 0 and solve for x. The axis of symmetry can be found using the x-intercepts. Remember the axis of symmetry, and we're going to abbreviate that often with AOS like this. The axis of symmetry is a vertical line that goes through the center of the parabola, and it's always going to be x equals. And how we find that, it is the midpoint or halfway between the x-intercepts. The vertex can be found by plugging the x value in from the axis of symmetry to find y, because the vertex is always somewhere along the axis of symmetry. Let's take this information and use it to graph a couple of examples. In this first example, we want to graph y equals 2 times x plus 1 times x minus 3. So these are in factored form already. So how I would start this is I would set each of my factors equal to 0 to find my x-intercept. So I have x plus 1 equals 0. I would subtract 1 from both sides, and I get x equals negative 1. So we're here on the x-axis. I'm going to plot that point at negative 1. That x-intercept is negative 1, 0. And then I'm going to take the other factor and set that equal to 0. So I would have to add 3 to both sides, and I would get x equals 3. And I would plot that at 1, 2, 3 over right here. And that x-intercept is 3, 0. My axis of symmetry is somewhere between the two x-intercepts. And so you're just looking for the middle. This is the middle between them. You could actually add your x's, negative 1 plus 3, and divide by 2. If I add those x's, negative 1 plus 3 is 2. 2 divided by 2 is 1. And right here at 1 is my axis of symmetry. But you don't have to do anything that in depth. I mean, you literally are counting and making sure you have equal spaces. 1, 2, 1, 2, and at 1 is my axis of symmetry. So you want to graph that as a dashed line, and that's x equals 1 is my axis of symmetry, this vertical line right there. To continue graphing this, it helps us to find the y-intercept and think about whether it opens up or down. Opening up or down, remember, we're looking at the coefficient of our equation, and we have our leading coefficient, and that is 2, and 2 is positive. So that tells us that we are opening up. And then to find the y-intercept, that is when x is 0, what is the y value? And so you can simply plug that in. If we know an x value, we know that it's 0, we can plug that in. We can solve for y and have 2 times 0 plus 1 times 0 minus 3. 0 plus 1 is 1. 0 minus 3 is negative 3, and we have our 2 here. You can multiply those together, and we end up with y equals negative 6. And so we can plot that. I'm just going to roughly say that that's about right here. And so we put a point here. And with our axis of symmetry, what that tells us is there is going to be a point that is equidistant away over here. So it has a mirror point. So really, this point right here would be at 2, negative 6. And this point right here the y-intercept is 0, -6. And so we can imagine that our vertex would be somewhere right around here. To find our vertex, because we know our vertex is somewhere along our axis of symmetry, we can plug in that x value from our axis of symmetry. I'll just do it where I have a space over here. Y equals 2. Our axis of symmetry happens when x is equal to 1. So it's going to be 1 plus 1 times 1 minus 3, because we're just plugging in this particular x value in the x spot of our equation and then simplifying. So I have 2 times, and then 1 plus 1 is 2. 1 minus 3 is -2, and if I multiply all of those together, I get -8. So my vertex would be at 1, -8, which would be right around here. So 1, -8. And this is just a rough sketch, but you can see we get that nice U-shaped curve that we can connect. And that's the graph of y equals 2 times x plus 1 times x minus 3. In the second example, we have y equals 1/2 times x minus 4, x plus 2. So we already have this in factored form because it's written as multiplication, which means we can take each of our factors and set them equal to 0. So x minus 4 equals 0. If we add 4 to both sides of our equation, we get x is equal to 4. So that would be right here at 4. And then we can take our other equation, our other factor, x plus 2, and set that equal to 0. We would subtract 2 from both sides to get x equals -2. And we would plot that where x is equal to -2. And then to find our axis of symmetry, we're going directly between these two values again. And it turns out, if we count, we're 3 away from, each side is 3 away from x equals 1. So that's where our axis of symmetry is. And so we'll write that down here, x equals 1. Oh, I forgot to write my intercept, so let's do that. So we're going to have 4, 0 for our one intercept and -2, 0 for the other. If we are trying to find our our y-intercept, we're going to have x is 0. We're going to solve for y, so we can do that right up here. 0 minus 4 and 0 plus 2. 0 minus 4 is -4, 0 plus 2 is 2. So we can multiply these all together and we get -4. So 0, -4 is my y-intercept. So that might be somewhere right around here. And then I am 1 away from my axis of symmetry. So I know 1 away over here, I'm going to have a partner point. I'm going to go ahead and plot that right here. That would be where x is 2. My y is also going to be -4. And again, on this example, I know that somewhere down here is going to be my vertex. And we can find that again by plugging that in. So we know that the x value along that line is 1, right here from our axis of symmetry. So I'm just going to plug that into my equation, find out the y value when x is 1. So 1 minus 4 and 1 plus 2. 1 minus 4 is -3. 1 plus 2 is 3. And so we end up getting -9/2, or you might think about that as -4.5. It might be easier to graph. And so my vertex is when x is 1, my y value is -4.5 or -9/4. And so that would be somewhere below, which makes sense when it's opening up. Of course, we didn't talk about that yet. Why is this opening up? It is opening up because our a value right here is positive. And so we can continue our curve. And you can see that this graph is a little wider. That 1/2 tells us that the steepness is a little bit less in this. And the steepness over here, when it was 2, is going to be more steep. So let's flip to the back side. Examples 3 and 4 match the ones on the front. They are already in factored form. So you're ready to set those factors equal to 0 to find the x-intercepts. Examples 5 and 6 are not yet in factored form. We'll need to factor those first. Pause here to graph number 3. In this example, both of our factors are the same, so I'm only going to get one x-intercept here at 3, and there's nowhere to go halfway between, so it is just my axis of symmetry is right through that point. And remember, our vertex has to fall on our axis of symmetry, so in this case, it means that our x-intercept and our vertex is the same. And we can still find our y-intercept. I found that, again, by putting x equal to 0 and solving for y, and I got positive 9, which is right here. That makes sense because it's above where my vertex and my x-intercept is, and my parabola should open up because it has a positive. There's no negative here, which means it's positive. My a value is positive, so it opens up. And I know that if this is 3 away from my axis of symmetry, then I have a partner point over here, a symmetry point over here at 3, 9, and that was enough information to get a rough sketch of my parabola opening up. So I want you to pause right here as we graph this equation, y equals negative 2x times x minus 6. Hopefully you got a curve that looks like this, opening down because of my negative leading coefficient. And I let negative 2x equals 0. I divided both sides by negative 2. I got 0 right here. And x minus 6 equals 0. I got x equals 6, or 6, 0 for my other x-intercept. Halfway between those was right here where x was equal to 3. So x equals 3 was my axis of symmetry, which meant the x spot of my vertex was 3. I plugged that in right here and got y equals 18. So just did a different scale, roughly put that, I know it's going to be up here. So I don't have a partner point because it's on my axis of symmetry. It's the only point that doesn't have a partner point is my vertex. And then you probably could just note that where I cross the x-axis or the y-axis is 0, 0, given that the x-intercept is at 0, 0. But you can also plug it in up here when x is 0. If you simplify that, you also get y is equal to 0, but you might just be able to infer that from graphing the x-intercept that you got here. And then I just connected the 3 points that I had to make a rough sketch of my graph. For these last 2 examples, I don't have them already written as multiplication. I don't already have them written in factored form, so I have to go back to what I know about factoring. And on number 5, the first thing I'm going to do is I'm going to divide out the greatest common factor. So I'm going to divide 2 out of each one of these, which means I'm going to have a coefficient of 2 out in front. And what's left over is going to be x squared plus 6x plus 5. Now you're ready to do this in the box method, if that's how you do this. X squared plus 6x plus 5 would go along my diagonal. And I am looking for factors of 1 times 5, so that's just 5, factors of 5 that add up to 6. And my first, or my only factor pair, 1 and 5, do add up to 6. So 1x and 5x can be written here. Those values could be exchanged. And factoring out the greatest common factor of each row and each column. These would be my factors. So x plus 1 and x plus 5 are my 2 factors. And I can set my factors equal to 0. So if I set x plus 1 equals to 0, I will get x equals negative 1, which is right here. If I take x plus 5 equal to 0, I would subtract 5 from both sides, and I would get x equals negative 5. I would plot that right here. And negative 5, 0 would be my other x-intercept. And then remember, my axis of symmetry is going to be right between there. And you can see that this is halfway between. It gives us 2 on either side. So I'm going to draw that vertical line right here. That is going through at -3, which means my vertex is going to be somewhere on that line. So its x part is -3. You have to plug in to find that. And so I guess I'll just do that first. It's up to you where you want to plug that in. You can plug it into your original equation or the factored form. I think it's kind of easier to do multiplication in this case, so I'm going to plug it into the second one, but it really will come out to the same thing either way. So -3 plus 1 and -3 plus 5. So that's going to be -2 and +2. So if I multiply all that together, I'm going to get y equals -8. So if I plot that, that's going to be somewhere right around here. Let's say at 3, -8. To get my y-intercept, I actually like to plug into the original for my y-intercept because you can get it very easily. You can get it easy in the other place as well. But let me show you what I mean by plugging it into the original when it's not in factored form. So that would be 2 times 0 squared plus 12 times 0 plus 10. Anything times 0 is 0. Anything times 0 is 0 plus 10. So you end up with just the constant. And that will always happen that way. So when x is 0, y is 10. It's always the c value when you're in standard form. So it is hitting somewhere way up here at 10, and it's going to have a partner point. So this right here is 3 away. So if I go 3 away over here, and that's kind of in the middle of my writing, but you can kind of get the idea that it would be right here. That would be at -6 for x, and y would be 10 just to have its partner point, and then we can sketch the curve. And you can see it opens up, and that is confirmed by the fact that I have a positive coefficient. In our last example over here, y equals 3x squared minus 15x. If I look here, I have greatest common factor of 3 for the numbers and x for my variables. So when I divide out a 3x, what's left over is just x minus 5. So I can set my factors equal to 0. So 3x equals 0. If I divide both sides by 3, I get x equals 0. So this is one of my x-intercepts at 0, 0. And then I can set my other factor equal to 0, x minus 5 equals 0. And if I add 5 to both sides, I end up with x equals 5. So that would be right here at 5. And my intercept would be 5, 0. And I know that my axis of symmetry has to be halfway between. And this is the first one we've had this way, but we don't have a whole number. We're dividing 5 by 2, and that gives us at 2.5. And that is okay for that to happen. So my axis of symmetry is just x equals 2.5. This happened once before, but we can see here that if our x-intercept is also on the y-axis, that is also our y-intercept. And so to get another point on here, we do know that this is going to open up because 3 is our leading coefficient right here, and it's positive. But to be able to graph this, so we know that it's going to be our vertex is going to be somewhere down here. And if we wanted to find out exactly where that was, we would plug that x value in to either one of our equations. I would plug it into my top equation, and then you can plug that whole thing into your calculator to find out what the y value is. And we get -18.75. We don't have to worry about exactly where that is. We're just going to roughly know that it is down here on the bottom part of our y-axis. So at 2.5, it comes out to negative 18.75. That's roughly where I've graphed it. And I can connect my graph here, and I get a rough sketch of my parabola.